Okay, so now we will see about the error and type of error when we measure any physical quantity using the instruments. So error are of two types, random error and systematic error. Random error occurs due to unpredictable fluctuations in experimental conditions. So it is totally unpredictable. And that is the reason that it cannot be removed completely. A random error cannot be removed completely. There will be a little bit of random error present always. So it cannot be removed completely. Whereas systematic error, it happens, systematic error comes because of three reasons. Maybe our equipment is not that much accurate, so that is called instrumental error. Instrument error. Maybe our instrument is correct, but we have some technical error, means how to use it, or what is the proper setup required. If you make mistake in that kind of thing, then we are bound to get the error. So first, instrumental error, second, technical error, and third is biased personal error. So even though if our instrument is correct, even though our technique is correct, but due to some personal mistakes, like you can say that biased mistake will lead to the systematic error. Now, these three errors can be removed completely. So, we do not measure systematic error because it can be removed completely. Example of systematic error is zero error. Zero error belongs to systematic error. Whereas random error example is parallax. So, parallax error is the example for random error. Now, random error also happens because of instrumental design or the technique adopted, because no instrument is 100% perfect, no technique is 100% correct, right? And also this random error occurs due to unbiased personal error, means by mistake you are doing mistake. So that is unbiased personal error. Now we have to calculate the error. We have to calculate the error due to random error. To reduce the random error, it is always suggested to repeat the experiments, to repeat the experiments as much number possible, right? As many times possible, and then you take the average. When you take the average, then it the error that we get, it is reduced. Okay, but obviously it is not nullified. Now let us take uh, let us take into the consideration of random error. And let's say we have measured one physical quantity. Now how to write that measured quantity? For that, we will do like this. Any measured quantity can be written like this one. X is equal to x naught plus minus delta x naught. Here x is the measured quantity. It may be force, it may be mass, it may be time, it may be velocity, acceleration, any physical quantity that you are measuring with the help of measuring instrument. And this x naught is called true value. This is called true value. It is also called mean value. It is also called target value. It is also called absolute value. Okay. Whereas this delta x naught, this is called absolute error. This is error. This is also known as uncertainty. Absolute error has same SI unit. It will have same unit as that of the x naught. Now, there is another kind of error calculation we do, which is called relative error. Relative error. So, a relative error is denoted by del. So, del x naught. Del x naught is written as absolute error divided by the mean value. This gives the relative error. If we multiply 100 to it, that will give us the percentage error. That gives percentage error, that is delta x naught by x naught into 100. Now these are the three kind of error calculation that we need to do. Let us take one example. Let's say we have calculated mass of an object by using some measuring instrument, and we are getting 100 plus minus 2 kg. So we will say that 100 is the mean value or absolute value that we are getting, and 2 kg is the absolute error. So we will write that in this measurement, our absolute error is, that is delta m, is 2 kg, because this mass calculation can vary from 98 kg to 102 kg. So this variation is 2 kg. And the relative error in this measurement will be 2 over 100, that is 0.02. Remember, relative error will not have any unit, it is just a ratio. Then we have the percentage error. So in percentage error, what we will do, whatever relative error you are getting, just multiply by 100. So this we will get as 2%. So this is how we calculate the errors in a physical quantity measurement. Now we have propagation of errors also. So we will discuss it shortly. Thank